The problem: a tsunami of requests. Every second on the world's largest social network, billions of requests race through its infrastructure. A single page load can demand hundreds of pieces of data. Curing the primary database for every single one would bring the system to a halt. This is the core challenge Facebook engineers faced: how to build a shield for their databases that is fast enough, consistent enough, and vast enough to handle a planet-scale workload. Their solution? Transform a single caching tool, Memcache, into a globally distributed, intelligent key value store. Foundational architecture, separation and consistency. Their foundation is a powerful separation of concerns. MySQL handles permanent safe storage. Memcache handles fast temporary access. This allows each layer to scale independently. The rule is simple: check the cache first, fall back to the database only on a miss. When data is uploaded, the cache doesn't refresh. Instead, the outdated entry is simply removed. This method is straightforward and repeatable without side effects. However, this approach is inadequate at a massive scale like Facebook. This leads to two questions. How do system architects then stop a single cache miss from triggering a stampede of simultaneous database queries? And how do they guarantee that thousands of servers all serve the same exact consistent version of the data? Scaling within a cluster, the micro battles. First, within a single data center cluster, the battle is against latency and overhead. A web server might need to talk to hundreds of cache servers for one page. A simple slow server can drag down the entire request. Their secret weapon? Empower the client. Facebook's smart client libraries and McRouter proxy handle the complexity. Using UDP for gets and to slash latency and overhead, implementing a sliding window for congestion control, preventing network incas, batching many keys into one request, dramatically reducing the round trips, and to solve the thundering herd, they invented leases, a temporary token given to the first client after a cache miss. This client alone repopulates the cache, while others wait, protecting the database. Scaling across the globe, the macro system. As Facebook expanded globally, its infrastructure needed to span continents. The core engineering challenge was enabling rapid local data retrieval while ensuring all write operations synchronized worldwide. This complex data distribution was orchestrated by McRouter, the system's global brain. They operated a regional master model. One region holds the authoritative data and broadcasts a stream of changes. Other regions follow this stream asynchronously. This means cross regions might be slightly stale, a deliberate trade-off for the blistering local speed and availability. They measure this trade-off precisely. A catch invalidations are 99.9% reliable within a region in under a second. Cross-region network unpredictability lowers this slightly, a reality their system is built to handle gracefully. Rewriting the rules, enhancing Memcache itself. To bear this load, Facebook didn't just use Memcache. They re-engineered it. They replaced its global lock with a fine-grained locking, tripling throughput. They made the memory allocate adaptive, continuously rebalancing to match shifting workload patterns. They also created the transient item cache, a separate fast lane for short-lived data that gets purged the instant it expires, saving precious RAM. And by storing cache in shared memory, servers could restart without jumping their data, enabling seamless upgrades. They considered other complex systems but chose to enhance Memcache. Why? It's stateless. Simple and predictable nature is a superpower at this scale. It is a lesson in choosing the right foundation and making it extraordinary. The engineering philosophy conclusion. So, what's the ultimate takeaway? This paper is a masterclass in pragmatic, large scale engineering. It designs for failure by monitoring gradual rollouts and fallbacks that are critical as the algorithm. It embraces strategic trade-offs by prioritizing availability and latency and accepts eventual consistencies where it makes sense. It builds on simplicity by a simple stateless core component that is easy to scale, debug, and make reliant and resilient than a complex monolithic one. It iterates relentlessness. This architecture wasn't designed in a day. It was evolved through constant iterations under real-world pressure. Facebook's Memcache system is not a theoretical design. It's a battle-tested living artifact that balances raw performance, resource efficiency, operational sanity, and user experience at a scale few will ever see. It shows the greatest systems aren't just built, they're grown under pressure, one smart decision at a time.